Okay, in today's lab, we're going to be learning about a special kind of solution called an alloy. Now, solutions are a homogeneous mixture where you have two types of particles mixed together evenly to the point where everything looks the same throughout. So the mixture is spread out evenly. Think of it like Kool-Aid, where you have a solid dissolved in a liquid. Now with alloys, you have two metals where you have one metal dissolved in the other. But when they're mixed together, you get a homogeneous mixture that is the same throughout when you look at it. And also if you dissect it, you can see that it's the same throughout. Now, how does this work with metals? Because metals are typically solid. What you have to do is you have to cheat a little bit. So you take the two metals, melt them down into the liquid form, and then mix them up a little bit. And then you create an alloy. Now, alloys can take two forms. Substitutional, where the ions of the metals are about the same size and they just switch spots. Or you have what are called interstitial, where you have a smaller ion or a smaller atom in between the gaps created by another metal. Carbon steel is an example of an interstitial alloy where you have carbon atoms in between the particles of iron. In this lab, I will be showing you how to make brass. And the reason why brass this time of year, it kind of looks like gold. In many cultures and in many religions all around the world, gold is seen as a very special kind of metal, especially in the holiday times. And alchemists back in the BC times, early days of chemistry, before it was officially chemistry, they tried to make gold out of just about anything. And they thought they had something when they made brass. In that combination, you have zinc and copper combining into something else that looks like gold but really isn't. And I'll show you on a smaller scale in the lab how that can be done using some chemicals and some of the lab equipment. It's a quite dangerous lab given what's in it, but when you see the materials and you see how it works, you'll understand why. So let's go to the lab and see how this all works. Materials for today's lab include Bunsen burner, beaker of water, some zinc, and some 5 molar sodium hydroxide, which is very concentrated. Be very careful of this stuff right here. And we have a peppering dish, we have crucible tongs, and we have a hot mat. The other piece of equipment you'll need is a hot plate. The hot plate should be set at 4 as opposed to 6 or high. The reason being, you don't want to boil away the sodium hydroxide solution because the vapors are irritating. While the hot plate is heating, add the zinc to the evaporating dish and pour into it the sodium hydroxide solution. The high concentration of the sodium hydroxide solution and the heat turns the zinc metal into an ion called zincate. The formula is in the ticker below. To the mixture, add very clean copper pennies. You want the copper pennies as clean as possible so that no debris or weight or residue on the surface reacts with the zinc solution. In the process of reacting, the zincate ion reduces to zinc, causing galvanization or forming a zinc layer. Now, compare those pennies that were just put in to this one here, which isn't as clean. It's hard to tell, but in real life you'll see that there is a layer of residue on the penny that would cause a side reaction or maybe even cause the reaction to not occur at all. So you really want to make sure that the pennies are as clean as possible throughout the process. So now, even though it's heating and it does take some of the time off, it still takes a while. So making sure that the pennies are coated with the zinc pellets kind of helps speed up the process. How long it takes depends on the purity of the copper layer and the heat that's applied. I would say this probably takes about 15 minutes. Okay, so it's been about 15 minutes. Let's see what the reaction looks like now. So as you can see, the copper looks like it's gone. It has been replaced by a layer of zinc. This is what the galvanization process looks like. And it has the silvery color that you would expect with zinc. Now you can still see little bits and pieces of the copper layer shining through, so it's a very thin layer. In fact, if you took an abrasive surface or your fingernail, it would really scrape off. But what happened there was the zinc ion in zincate reduced to elemental zinc, which has no charge at all. Now it's time to rinse off the sodium hydroxide solution off the pennies. To do that, all you really need to do is to dip it in that beaker of water. That also cools down the mixture to make sure that it is at room temperature and ready for the next step. It is tricky to get it out of the evaporating dish because you really want to hold the pennies by the edges, because holding it on the flat surfaces, you run the risk of scraping off the thin layer of zinc. Now, what you want to do is also dry the pennies just to make sure that no water interacts with the last step. So patting it dry is the preferred way of drying these. Now you can see the final product, at least for this step anyway. The copper penny is at the beginning there, and you can see two galvanized zinc pennies that look silver. The last step in this process is to take the zinc-coated penny and heat it in a Bunsen burner flame. That heating causes the microscopic layer of the zinc and the surface layer of the copper underneath to mix. And in that mixture, they will evenly distribute amongst themselves, creating a substitution alloy. The appearance of that alloy is such that it looks like an even coating of brass, which looks gold in appearance. And because it's even looking, that is a homogeneous mixture. Make sure to cool the penny in the water when you're done. So there you have it. A copper penny was converted into silver through galvanization with zinc, and then with heating, the zinc layer and the copper layer underneath mixed together to form brass, which is gold-like in appearance. The even coating and the even appearance of the brass means that it is a homogeneous mixture caused by the mixing of the two metal ions, copper and zinc. So that is the process of turning copper into silver and gold just in time for the holidays. So make sure that you look at the questions and the discussion in the lab handout and do your best to answer the questions. Ask your instructor if you have any more questions about the process of turning copper pennies into silver and gold. Thanks for watching. So that was pretty cool, huh? Taking the copper, transforming it into zinc, so to speak, by putting a layer of zinc on top of it, and then using a little bit of heat to cause the atoms of zinc and copper to mix together to create the brass that looks like gold. Again, I think the alchemists back in the day probably made that and thought they had gold, but it really wasn't the same. Anyway, I hope you enjoyed the video, and it is a very unique take on solutions, as it is a very unique and special kind of situation. If your instructor has provided you with some questions, use the time in the discussion about solutions and the whole idea of having substitutional versus interstitial alloys. See how that works. Here's a hint. Zinc and copper are about the same. If you look at them on the periodic table right here, they're about the same position in the transition metals side by side, which means that their radii are probably very similar when you put them together. So think about it, answer the questions that your instructor provides you, and have a very happy and healthy holidays this year. Thanks for watching.